Hello everyone, in Shankishpur from RT Thread organization. We recently released RT Thread version. We released RT Thread version 5. And I am very happy to take this opportunity to share with you some new progress about new version. From 2006 to now, with the efforts of the community, RT Thread has gradually added new features such as file system, network device framework, multi-core support, etc. From the initial basic RTOS, now it supports more architectures in DSPS and has developed into a feature-rich microcorridor RTOS. At the end of 2020, we merged the RT Smart branch into the main line and released 5, marking an important milestone. 2 years later, we are pleased to announce the upcoming release of 5. And this new version includes improvements such as optimizing the scheduler and enhancing SMP multi-core performance, which I will introduce in detail later. First, let's take a look at the system architecture diagram. The system architecture is divided into kernel state and user state. Kernel state adds support for lightweight processes and system calls, such as process management, inter-process communication, ELF loader, and other modules. Compared with Linux, RT Thread's kernel can be as small as 500K, which improves the startup speed and supports manukified custom kernel functions. User state applications consist of two-part system services provided by RT Thread, such as file system, network, UI support, etc. Allow some kernel components to run in user state, realize dynamic disassemblability and restart, and improve system stability. In addition, RT Thread also provides a complete user state application development SDK, which supports RT Thread native and POSIX interfaces, making it easy to migrate existing applications or port Linux applications. RT Thread natively supports POSIX API development. You can write POSIX compliant code in C files, such as creating threads using the thread interface. You can then compile this code using the dedicated toolchain provided by RT Thread to generate ELF files that run on RT Thread. With the RT Thread VS Code plugin, you can enjoy a seamless development experience. With the release of RT Thread, several GNU applications have been ported to Userland, including LVGL Weston, FPent, and MicroPython. A device tree parsing mechanism has been added at the driver level. Drivers can now be registered by dynamically loading and parsing the device tree, improving system portability and providing better multi-core and 6-bit support. Let's take a look at some functional updates of the RT Thread kernel status. In the kernel section, the macro switch for RT Thread Nano has been added, and users can use the N tool to switch to the Nano version with one click. The CPU scheduler has been optimized. Time slice parameter checking has been added to the thread creation function, and the RV6 for RTOS kernel battery support has been introduced. In the device framework section, general software simulation of ITC has been added, as well as device tree support. The console that has auxiliary command completion function. In the component section, DSNF to now includes symbolic links and ordinary file management, and XFAT configuration has been added. The FIL component now includes a block mechanism to support special block definitions, and an NPU abstraction layer design has been introduced. In the limit section, GEC general atomic operation functions have been added. In the architecture section, support for ARM Cortex, MA-type within Cortex, R5 Tatio has been added. In the tool section, the NB version has been updated to 1. Fifth audio and support for the LLVM toolchain and new commands has been added. From version 5.2 to 5.1.0.1.0, the RT Thread community has released a number of open source development boards covering areas such as education assessment, IoT, human-computer interaction, and machine vision. During this period, Studio has also released multiple versions and updated support packages for various development boards. The number of software packages has been steadily increasing and is now close to 700. Now let's look at the package part. With the release of RT Thread, our packages have also undergone many updates. The total number of packages has now reached 690. First, let's look at the peripheral part. In the new version, the STM32 and Infinite and non-HL libraries have been separated from the mainline. This has greatly reduced the size of the repository. Second is the system-related packages with 6 new packages added. These include a cross-platform real-time system Bakebucket framework and components for the ThreadX ecosystem. Also, in the IoT section, support for Infinite YW series WIP by the LE modules have been added. In addition, lightweight Modbus protocol stacks such as FC, Modbus, and Modbus have been introduced. In the I direction, 2 tiny ML-related packages have been introduced to quickly deploy ML deep learning models on MCS. With the release of RT Thread version, we have also updated support for many BSPs and chips. Let's take a look at the ARM architecture first. We have added support for many new manufacturers' chips organized by Series BSP. This includes Renesas RISE series and XPN CX series. In addition, we have launched some open source hardware, such as the Vision board within a type of core and the upcoming RTP generation with a 7R core. Let's take a look at the RISC-V architecture. Currently, V has a very comprehensive driver, including pins SPI, EWM, SDI, and Ethernet. We believe that the RT Thread RV ecosystem will be more complete in the future. These updates ensure that RT Thread continues to support a wide range of hardware and remains versatile for a variety of applications. Arduino is the Arduino ecosystem compatibility layer of the RT Thread real-time operating system. It is a sub-community under the RT Thread community under the RT Thread community RT Thread software package ecosystem and reducing the learning difficulty of the RT Thread operating system and adapter chips through Arduino. Users can easily use RT through Arduino functions and programming methods, and can also directly use third-party libraries of the libraries of the Arduino community in RT Thread projects, greatly enriching the RT Thread Thread ecosystem. Arduino has high compatibility with Arduino interfaces, allowing developers to seamlessly apply rich Arduino sensor libraries to the RT Thread environment without tedious code rewriting or adaptation, bringing great convenience to developers.
Here is a list of user space applications supported by RT Thread. For example, we have a BusyBox tooltips, AST4 file system, and Bash command line. In the network category, SHD and HTTPD are currently supported. Media supports are currently used tools SDL2 and FMPG, as well as LVGL. The language category is quite rich, including MicroPython, Lua, and JavaScript as QuickJS. In the AI category, there are currently OpenMV and OpenCV. Here are some user space applications. First is Winston. Winston is the Windows display protection. Currently, Linux distributes was relevant for multi-Windows display. Okay. Next is FMPG, code libraries that include built-in H264 decoding. Below is the demo list of the FMPG user space applications running on D1S platform, playing a MP4 video. So how to carry out the user's mode development? First, use Xmix to build the user mode applications we have written. Then package it to make root force. And finally, mount the file system and run in the RTSmart. So what hardware can we used to experience the user mode applications of RTThread? First, the ARM series. There are two BSP, QEMU A9 and ARC64, which can be experienced, and some real hardware, such as Raspberry Pi and Max series, ZYNQ, and the RISC-V series, which have QEMU support and is a 64-bit BSP. The real hardware can be used is the all-winner D1S series. Finally, how to experience the smart features of RTThread. First of all, you must read the documents to get started quickly. Then get the code, including kernel code and user mode code in the SDK. Then download the env VS Code plugin and follow the instructions in the Getting Started documentation to experience the RTSmart of RTThread 5.1.0. If you have any questions, you can feedback through from the GitHub or Git in the issue. Okay, finally, thank you for your watching, and I hope that my presentation today is helpful to you. Thank you.
Well, thank you so much, Jan. That's wonderful. It's amazing to me to see just how fast RTThread has grown and how expansive it now is. It's mind-blowing. We have a few minutes to wait before our next speaker. So I'm afraid you're going to have to listen to me. There are a couple of things I was going to tell you about. If you're looking for a good book, this is one I would recommend, Humble Pie. And it's about all well, you can see from the aeroplane with the wings the wrong way. This is all, it's a series of very amusing engineering problems that occurred because people didn't pay attention. And it's a valuable lesson to all of us, I think. And another book that only just has come out, Dead Simple Python. And although it says dead simple, this is not an introductory book. You have to at least know programming languages. And it's not a thin book. But this really tells you everything you need to know to use Python to make real world projects. This is very heartily recommended. So I believe our next speaker has joined. So we'll be turning over to him in just a couple of minutes. I would engage you all to communicate via the chat. it's a good way to reach out to meet people. I'm looking at all the people joining from Zimbabwe, Vietnam, Ghana, Brazil. So this is a great way for us all to make connections and get to meet everyone. Okay, so our next speaker is in fact ready. Mohammed Dogar, Vice President of Renesas Electronics Corporation. Mohammed is the head of Global Business Development and Technology Ecosystem for Renesas Electronics. And the topic of Mohammed's talk is Industry 5.0 and collaborative robotics. I only just got used to Industry 4.0, Mohammed. You'll have to explain where the 5 came from. Yeah. Okay, over to you.
Thank you, Max. Appreciate the opportunity and welcome all. Seems like we have a real global audience here. So I'm just going to share my screen. Hopefully you can see it. Okay, so yeah, once again, thank you very much for joining the session. I'm really excited today to talk about the Industry 5.0, and I will talk about this, what that is, and more importantly, what's happening in the world of robotics, and I'll touch on specifically on the collaborative robots, right, and how it's going to help the industries and automation at large. My name is Mohammed Dogar. I head up the Global Business Development and our AI Center of Excellence here at Renesas, and really pleased to giving this talk today. So let's make a start. So I'm going to be touching on a few key areas today. Certainly want to talk about the market trends, and I'll explain what's happening in the evolution in the industrial space reaching 5.0, and then I'll dig a little deeper into the industrial robot use case. What are the key system configuration? What kind of building blocks do we need? And more importantly, how Renesas can help achieve these solutions, and what we're doing with our partner RT Thread in terms of our collaboration, and I'll wrap up. There'll be some time for questions, but feel free to post them on the chat as well. I have my colleagues also joining, and they can also take, or I can answer those questions. Okay, in terms of the trends, let's look at the market. So certainly industrial market is on the rise. I know we're going through a little bit of a market correction right now, but industrial automation at large, we're seeing, of course, a huge industrialization. The promising compound annual growth of around 8%, reaching out 280 billion worldwide. And then specifically, you should look at the servo motors and the drives market. And the reason I'm bringing this up is, you'll see in my presentation that motors are going to play a key role, of course, in the robotics and the industrialization, and that's almost 15 billion already. And then the robots themselves, the industrial robots, we're looking at not the consumer, but real industrial devices, is really growing significantly across a whole range of industries. So I think my message here is the industry is there, the market is there. What do we do to capitalize on this growth? And really, for what we're seeing from our side at Renesas is, how can we help our customers to have, these leading solutions? In terms of the market trend, so certainly one thing we are seeing is the security aspect. So there's a lot of legislations, but certainly in Europe, there's a European Cyber Resilience Act that demands to add security to the industrial devices that really ask for a full end-to-end security solutions and reporting and infrastructure as well. And reason I'm bringing the European aspect in is, of course, anybody selling into Europe will have to comply this as well. But similar kind of acts are also are present in the US and other Asian, China, other areas as well. And of course, the one of the key thing, let me just actually get rid of all the animation. So one of the key things when you look at the edge processing, you see a convergence in the IT and OT space, and that's really happening with the increased CPU performance, and more importantly, when we're trying to support the industrial real-time communication deployment. AI is everywhere, but certainly the maturity level of AI when it comes to predictive maintenance, and certainly where we have the motors involved and where we have applications where we need real-time anomaly detection, others is on the rise as well. And finally, looking at the collaborative robots, of course, there is a general shortage of labor, but one thing I really also want to address today is that how collaborative robots, not just for simple tasks, but for complex tasks as well, working hand in hand with humans. And as we talked about industrial automation, as we talked about robotics, functional safety is extremely important to make sure that humans working with the machineries are safe and they're working in a safe environment. So so really some key trends here that's really enabling the growth and establishment of this market. So talking about Industry 5.0, so we all know Industry 1, this is mechanization, it kind of, in the 1800s, it started in the water, certainly some of the steam stations that was there. Of course, moving on to different generation, Industry 2, Industry 3, where you start to see more of electronic being embedded, certainly, an automation happening at the assembly line, production, and adding more electronics. And the last decades or so, we've been working, of course, Industry 4.0, which is basically cyber physical system, which means that the systems that's installed in the factory floor are actually being networked and also communicating to the back end, making more efficient systems, enabling machine learning. But when we look at the Industry 5.0, the actual enablement there is where humans and robots will work hand in hand, right? So this is not where a complex industrial robot is in a cage. This is about robots working in harmony, in collaborative relation, with humans, and that's the topic of the presentation today. I'll dig a little bit more on that. So in terms of use cases, if you think about industrial robots, of course, certainly robots are helping the automation, helping fill the gaps of where we have shortfall in terms of labor, but also I think where we have more intelligence being deployed in terms of machine learning or artificial intelligence. We're also seeing a lot of robots being used. And finally, some specialist partnerships, right, where industry and educators will emerge as well. So there's actually a whole host of applications that where the robots are being deployed. Let me change gears now and talk a little bit more on the industrial robots themselves. So if you look at this, the examples I have on my slides, we look at from the left-hand side, this is the centralized industrial robot architecture. Typically, this is what's established, or, if I may also call more of a legacy system, where, all the intelligence is in that single robot, right? So in this case, it's a typical, drive system, perhaps on a factory floor. You have multiple motor drives running, and you have one single robot controller who's trying to control different aspects of those motor systems, as well as, of course, giving feedback into the network for communication purposes, right? But if you look at moving forward, the intelligence is being distributed, right? I mean, we call it distributed intelligent or distributed industrial robot architectures. And here, basically, all the intelligence is distributed amongst the system, right? And it's spread out across the network. Each drive in this case, motor drive in this case, has independent controllers. It's more modular approach. It's more flexible and higher optimized performance as well. And this is really where the industry is now moving to be able to have, more distributed. And that's